Hello and good day, geometry. I'm here with you going over PO19, using what we talked about in CO18, those angle relationships with a transversal. But now we're going to focus on what happens when you've got a transversal with parallel lines. Okay, we've kind of prefaced this before a couple times that parallel lines really give us some cool relationships. That happens here with a transversal. So for starters, let me just point out, this symbol on lines here, that little triangle, means that those lines are parallel. Okay, and parallel lines, their definition, with lines that will never intersect. Okay, lines that will never intersect. They will never cross. And what happens when you have a transversal that intersects two or more actually parallel lines is that, number one, those corresponding angles that we talked about in CO18, corresponding angles are congruent. Okay, so if you've got parallel lines, if I'm drawing freehand, you can just kind of put little arrows in there to show that they're parallel. Don't have to draw the whole triangle. If you have a transversal between two parallel lines, corresponding angles, same location, different vertex, they are congruent. Okay, the same measure. The same is true for alternate interior angles. Alternate interior angles are congruent as well. So let me draw my parallel lines, mark them parallel. There's my transversal. Alternate interior, opposite sides of the transversal in between our parallel lines, they are congruent as well. The same is true, there goes the pen, just cannot make it through a lesson. The same is true for alternate exterior angles, they are congruent as well. So here are my parallel lines, transversal, alternate exterior angles, opposite sides of the transversal, outside of our lines being intersected, they are congruent angles as well. The one that's different is consecutive interior, and consecutive interior, I'll do it in blue because it's not the same as the other three, they are supplementary. Okay, so for example, got our parallel lines, transversal cutting through them. Our consecutive interior angles would be right here and right here is one pair of them, right? Looks like a little person actually, kind of. Hi there, buddy. They're on the same side of the transversal, on the interior, inside of our lines being intersected. If this was, for example, 80 degrees, this one would be 100 degrees. Okay, they are going to sum to 180. That's the only relationship here that we're going to talk about that does not involve congruent angles. Okay, so getting down to some examples of this and how we can use it to our advantage here. It says, find the measure of angle 1 and angle 2, explain using one of the relationships above. So given this 54-degree angle here, we actually have a couple different ways now. Our toolbox is getting bigger, more tools, right? A couple different ways that we can solve for angle 1 and angle 2. You might notice that's something we've done before. 54 and angle 1 are vertical angles, right? So you can get angle 1 to be 54 and then look for that relationship with angle 2. So I'm just going to kind of redraw this down here. This is 54. If we know that that is 54 because of vertical angles, and we look at where angle 2 is, and we say, oh, hey, that's alternate interior, right? Alternate interior, opposite sides of the transversal, inside of the lines that are being intersected here, that's congruent with the 54, right? So you can use vertical angles followed by alternate interior angles. You could also notice that 54 and angle 2 are what? Corresponding, right? Same location, different vertex, both in that bottom left corner there. same location, different vertex. So you could get angle 2 first because of corresponding angles, and then notice that angle 1 and angle 2 are alternate interior, and that would make them congruent, thus making angle 1 54 as well, right? So you can go from 54 from the given angle to angle 1 and then angle 2. You could go from the given angle to angle 2 first because of corresponding, and then to angle 1. Or you could get each of them separately, vertical angles for angle 1, corresponding angles for angle 2. There are lots of different ways, okay? But the point is that seeing these relationships, without these parallel lines here, if these were not marked as parallel, we could still get angle 1 because it's vertical with 54, but we wouldn't be able to get angle 2, okay? But mark them parallel, and now we've got these relationships that form. Second one, take a look at this one. We got parallel lines there, transversal intersecting. The given angle, 95 degrees. We could here start with angle 1 or angle 2 again, okay? If you wanted to get angle 1 first, same side of the transversal, in between our intersecting lines, or intersected lines, that's going to be consecutive interior, meaning that 95 and angle 1 are supplementary. Okay? Angle 1 would equal 85. Then you could get angle 2 by saying, well, hey, angle 1 and angle 2 make a linear pair, so they add up to 180. They're supplementary, and angle 2 would have to equal 95 degrees. Or you could go to angle 2 first because of alternate interior angles. That means that the 95 and angle 2 are congruent, giving you an angle 2 measure of 95. Then you can either say, well, angle 2 and angle 1 make a straight line, linear pair, supplementary, or you could say the given angle, angle 1, consecutive interior, supplementary, and get the 85 that way. So again, multiple ways to get the same result here. And in this case, if we did not know these were parallel, we cannot find angle 1 or angle 2. So the parallelity, there I go making up words again, the parallelity is important. Last one here, parallel lines. That 135 is given. What do you think? There's really only one relationship to start with here, and that is going from the given angle to angle 1, recognizing they are corresponding angles, and that they are congruent. And then from there, go to angle 2. Okay? Angle 1 and angle 2 make a straight line. So because of the linear pair postulate, they will be supplementary, which would make angle 2 45. If you're wondering why I changed up kind of how I wrote my answer here, I didn't put the little m in front. I probably actually should have here. That little m stands for measure. Okay, and when you are giving a degree measure of an angle, you should probably have that little m in there. But sometimes you get so excited that I forget to put it there. Okay, but anyway, so corresponding and then linear pair to get angle 2. Okay, and then your homework, which is going to be these 3 questions here, and then of course the Google quiz. And the quiz for this, by the way, I'll give you until Saturday, so you've got the entire week to do it. With Thanksgiving thrown in there, it might be easier for you to get it done in the earlier part of the week, or if you're busy prepping and cooking and planning or other homework or whatever else, then you can wait till after Thanksgiving, a couple days, due Saturday. Okay, that quiz due Saturday. Find the values of x and y in each of these here. All right, same kind of thing that we've been working with. In that first one, I can go and get x or y first, actually. The relationship between 35 and angle x, they make a line. So it's a linear pair. So subtract 35 from 180, and we get the measure of angle X. In this case, actually, I wouldn't put the measure of just X equals 145. And then angle Y corresponding with our given angle of 35 degrees, that would be congruent. And so we get 350. 35-degree angle there. Okay, so 145 and 35 using a variety of relationships here. Linear pair, corresponding angles. This next one, two ways we can get at this. We can either, and I'll do half of it for you here. We can either go to Y, recognize that they are consecutive interior. Just look at those positions, right? Consecutive interior angles. And therefore they are supplementary, okay? So we could say that 180 minus 48 equals Y. You can solve it from there. And then recognizing that 48 and our angle involving X, their positions, alternate interior, meaning they're congruent, we've got the equation 5x minus 17 equals 48. You can solve for X from there. Okay, two-step equation to solve. Or you could also, once you get Y, recognize that this is a third option, secret option C here. Those two angles make a linear pair. So whatever Y is, you could set up that equation knowing that 5x minus 17 plus angle Y have to add up to 180. So you get at it that way too. The last one, similar type of situation. I'll let you look at it. See if you can come up with a plan yourself. In fact, why don't you go ahead and pause the video, do it, and I'll do this one in its entirety. But go ahead and pause the video, do the third one, and we'll compare. All right, so I'm looking at this, and I notice that these two angles make a linear pair, and so their sum has to be 180. So 2x plus 58 has to equal 180. Subtract 58 from both sides. We get 2x equals 122. Divide both sides by 2. And we get x equals 61. Okay. Then, to find the angle involving y, their position, their corresponding angles, so they're congruent, 2y equals 58. Divide both sides by 2, and we get y equals 29. Okay. Y equals 29. All right, so there you go. It's all about relationships, looking at where your angles are. Again, of course, first making sure that you have parallel lines here. Okay, that's important. But looking at where those angles are and digging in that toolbox. Are they vertical angles? Are they a linear pair? Now, are they corresponding, alternate interior, alternate exterior, consecutive interior, right? All of these different things give us information that we can use to come to a conclusion. Okay, so Google quiz due on Saturday. We'll press on with PO20 in tomorrow's lesson, so check back for that. Have a great day, folks. I miss not seeing you in class, but tis what it is. We'll be back after the week after Thanksgiving live. So until then, until tomorrow actually, have a great day, and do not forget to like and subscribe.